Welcome back. This is lesson 7.1 journal. We're learning about exponents. I will be able to identify the parts of an exponent. Understand what it means and simplify them correctly. So vocabulary for this lesson. You're also going to need your chapter 7 vocabulary page. So it should be just on the back side for you. Or the other page, okay? So an exponent is a mathematical operation that means repeated multiplication of the same base. So this right here is an exponent, all of this together. But there are two parts to it. We have the base, which is the bigger number, and we have the power. Okay? The base. So this is another one of our vocabulary words. Base is the number in an exponent that is being repeated or multiplied repeatedly. Okay, the power is a number in an exponent that tells how many times the base is multiplied. So for example, this base is 2, the power is 3. So that means 2 multiplied by itself 3 times. That's what an exponent means. Okay, evaluate means to find the value of. Alright, I think that is all of our... So if we were going to evaluate this, the value of 2 to the third power is 2 times 2, which is 4, times 2 again, which is 8. So this is where it's been evaluated. Now it has a value to me. This is what I had, this is what it means, and this is it evaluated. Alright, go back to the other page. So let's fill these out again. So we have the power in an exponent. We have the base in an exponent. What does it mean? It means 2 times itself 3 times. So what's it worth, or what's it evaluate to be? That would be 8. Now I'm realizing the word I meant to put up here wasn't simplify. I don't have a pencil, I hope you do. I want you to write evaluate. Evaluate them correctly. Alright, where in real life could we even use this? We have a few examples here. A bacteria doubles in number each hour. Use an exponent to represent the amount of bacteria present after 4 hours if you start with 2 bacteria. So, the base is what we're starting with, and it's going to double. So it's going to be 2 times itself. How many times? Well, if it doubles every 4 hours, that means I'm going to be multiplying. It's going to double every hour for 4 hours. So that would be 2 to the 4th power. So to evaluate, how many bacteria would we have? That would be 2 times 2 times 2 times 2, which is equal to 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So it would be worth 16 bacteria. Next, Chantel eats 7 almonds every day for 7 weeks. Use an exponent to represent the number of almonds she has eaten in all. So, 7 almonds every day that we're going to have to times by every day for every week, so that would be 7 days in 1 week. For 7 weeks, I'm going to be multiplying by 7 3 times, so this would be 7 to the 3rd power. So to evaluate that, we'd do 7 times 7 times 7. 7 times 7 is 49. Times that by 7 again, and we get 343. Alright, let's try this one. Abraham had half of a watermelon. He cut what he had in half and gave it to a friend. He cut the remaining amount in half and ate one of them. Use an exponent to represent the amount of watermelon remaining. So, we have half. Then we cut it in half again. Then we cut that in half, and then he eats half. So that would be 1/2, the whole thing, 4 times. So to evaluate that, that would be 1/2 of 1/2 of 1/2. How many times did we do it? 3 or 4. Half of a watermelon, there's 1. Cut it in half, there's 2. Cut the remaining in half. Okay, so that would be 4 times. So then 1/2 times 1/2 times 1/2 times 1/2. When we multiply fractions, we can't cross cancel anything here. So this would be 1/16. It has 1/16 of watermelon. Alright, complete the table to answer the questions below. So this right here, a lot of times on our calculators, that is how we would put in an exponent. So this would mean 2 to the 4th power, 2 to the 3rd power, 2 to the 2nd. Alright, so in expanded form, this means 2 times 2 times 2 times 2, which gives us 16. 2 to the 3rd power means 2 times 2 times 2, and that would give us 8. 2 times 2 gives us 4. 2 to the 1st power would just mean then 2. So its value would be 2. Well, now we need to figure out what 2 to the 0 power is. Let's see if you can find a pattern in these numbers. So this is half the size of this one. Divide this by 2 would give me 4. Divide this by 2 would get me 2. So what does 2 to the 0 power mean? It actually means 2 divided by 2. Well, what happens when you divide any number by itself? You get 1. Okay, let's see what happens with this one. 3 to the 4th power would be 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9, so 9 times 9 is going to give me 81. 3 to the 3rd power means 3 times 3 times 3. That would give me 9 times 3 is 27. 3 times 2, or 3 to the 2nd power means 3 times 3. That would give me 9. 3 to the 1 power would be 3. 3 to the 0 power, okay, follow the pattern. Divide by 3, divide by 3, divide by 3. This means 3 divide by 3. So what do we get? 1. So let's answer these questions. what will any number be to the power of 1? 2 to the power of 1 was 2. 3 to the power of 1 was 3. Any number to the power of 1 is itself. So what about any number to the power of 0? Well, this meant 2 divided by 2. This meant 3 divided by 3. So what will any number to the power of 0 be? It'll be itself divided by itself. Which, thank heavens, will always equal what? So it always equals 1. So anything to the power of 0 is 1. Okay, now down here it says prime factorize each number, then write the prime factorization using exponents. So 54, if I make a factor tree here, I know that 6 times 9 can give me 54. So if I'm going to prime factorize, I'm going to break this down. 6 times is equal to 2 times 3. 2 is prime and 3 is prime. 9 breaks down to 3 times 3. Okay, since everything ends in a prime number, so I could write this as 2 times 3 times 3 times 3, but because it's wanting it written with exponents, we're going to write each one. So this would be 2 to the first power, because I have 1, 2 being multiplied here, which I don't have to write that one, but I can. And then I have 3 times itself 3 times, so times 3 to the third power. So instead of writing them all out, that is a way we could write the prime factorization. Okay, let's try 100. So 100, break it down. I know that's 10 times 10. Those aren't prime yet. So 10 breaks down to 2 and 5. 2 and 5. Okay, those break down really well. And we are done. So 10. Now we always like to not 10, sorry, 100. If we break it down like this, then we have 2 times 2. So that would be 2 to the second power. Sorry, that's a 2 there. My hand doesn't want to listen to my head. And then 5 we had twice. So this would be 2 to the second power times 5 to the second power. Okay, let's try 33. 33, break it down, that would be 3 times 11. 3 is prime and 11 is prime. So if we're writing it using exponents, then 33 is equal to 3 to the first power times 11 to the first power. Alright, rate yourself on how you feel about this concept. Are you a 0, 1, 2, 3, or 4? Take a picture and turn it in on Google Classroom.